seconds late. I'll do an extra half hour. Hi, good morning, everybody. Hopefully you're ready for another enjoyable morning of chemistry with your host, me, Dr. White. A couple things. First of all, most of you have lab tomorrow. Check your email. Also announcement. Those who had lab yesterday and wondering what I'm talking about, put out an email for the section that you should be doing that I forgot to do for the Tuesday lab. So that's covered, but you should, all of you, always on a regular basis, especially a day or two before lab, check your email. All right. Now, yesterday, one of your colleagues had a really good question right after class ended. And I told the colleague, see me during lab, because on Monday and Wednesdays I have to leave quickly. One, there's another class coming in here, and two, I have to get to Elgin, where I teach also. But the question your colleague asked, I thought about it driving home. I said, that's a good question. One of the things I've learned in life is if somebody has a question, especially teaching, usually other people in the class have the same or similar question. So let's look at the question, and in order to do that, let's do the following. And let's look at the following problem. And if we look at, and let me decode it in case you can't read my handwriting, how many molecules sodium chloride are in 2.17 times 10 to the squared moles sodium chloride? So the first thing I like to do when I do, this is a good set, a word problem, is find out what am I asked to find, and the units. And the answer is molecules of NaCl. And then I look and say, what am I given? And if we look up here, we're given 2.17 times 10 to the second power squared moles sodium chloride. And I told you, if you ever go out to dinner, breakfast, or lunch with chemists, one of them, well, like all of them, will always ask, please pass the NaCl. Remember NaCl, sodium chloride table salt. Now, the question your colleague asked, which is a very pertinent question, a good one. All questions are good, but this is a good one. If you look at the screen, and this will be given to you in important information, it's the top part, I'll have to look. Which one of these ratios do I know to use? Well, the answer is you don't have to memorize that. You use your good buddy, your good friend, unit analysis. And let me show you how. Now, when you're trying to solve this problem, we've already gotten to this stage. And the only number I have to work with is that, so I'm going to put that down. Next, using your good buddy, your good friend, unit analysis. Remember, I'm going for the Guinness Book of World Record, saying it the most time in the next couple of weeks. What are we trying to find? What answer are we trying to get? And include the units. And it's right over there because we took the time to figure it out. Molecules, sodium chloride. Now, here's where your good buddy, your good friend, unit analysis really shines. And that is, if I can convert this to this with a ratio, what ratio would I use? Well, use unit analysis again. I gotta say it again, your good buddy, your good friend. Hopefully none of you are having nightmares hearing me say that, but whatever you're trying to get to goes on top of this ratio. So I look over there and I say, molecules, sodium chloride. Whatever I'm trying to get rid of, I do not want this in my final answer, goes at the bottom of this ratio. Now, when you have one thing equals another, you have these two ratios possible. You don't have to memorize this. Since you know one mole of molecule, and I could have put our element, equals Avogadro's number, this will be given to you. Once you know anything equals something else, you can put that into the ratio. And this is why you don't have to memorize it. We figured this out using unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. Where do I get those numbers? Oh, moles. Where do I have a relationship between moles and molecules of a compound? Right here. And it says 1 mole, so I'm going to put 1 mole there, and on top equals Avogadro's number. And that way you don't have to memorize which ratio. I know some teachers, chemistry instructors, I don't know if they're here, but in the past have made their students memorize that. For this type of problem, use this ratio. For the other type, no, don't memorize it. Use your good buddy, your good friend, unit analysis, and know when this equals this, you can put in a ratio. 1 on the top, 1 on the bottom, and you look what you need. Now, before going any further, did you do it right? Well, think about the units. Forget about the numbers. This is moles sodium chloride times molecules of sodium chloride divided by moles of sodium chloride. And remember, anything, one day I'll use a different letter, but not today. I'm stuck on A for this. Anyways, someone turned off the humor switch in there, or it was this awful humor. Probably both. Anyways, anything divided by itself equals the number 1. Therefore, moles of sodium chloride divided by moles of sodium, we're not looking at number, just unit, become the number 1, which means they're gone. Because 1 times anything is that anything. And I'm left with the right units, molecules of sodium chloride, and I know I'm on the right track to succeeding, which is always a fun thing to do. And let me open up my calculator, because I'll need it today. Now if we look at this problem, I'm multiplying it 2, I push enter, here's what my calculator gives me. Remember, you need to use proper significant figures for all calculated answers. Therefore, this is 3 significant, I'm in my rut again. This is always going to be in my class 3 significant. Therefore, your answer should be 3 significant. I'll give you 3 seconds to figure out how to round that off to 3 significant figures. 2.2, 2.6. Time's up. Keep the 1, keep the 3, keep the 0. Use the 6 to round off. Is that 4, 5, 4 or less, or 5 or higher? 5 or higher. So I drop that and everything else, change the 0 to 1. So that'd be 3.31 times 10 to the 26. And I think that answers your colleague's question. How do you know which ratio? Well, you don't have to know. You figure this out by using unit analysis, and you know this, and you can put the numbers in. And while I'm thinking about it, if you happen to scroll down the lectures file, of Blackboard, you'll see important information test 2. And if I open it up, you'll see at the end of test 2, second to last page will be a periodic table, you'll get all this. And notice the top one mole of an element equals Avogadro's number of the atoms. Second one mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules. And notice we went over this on Monday, and I'll be doing more today. The molecular weight of a compound is the sum of all atomic weights, and the other two things we'll be doing today and Friday. And then later on, I'll cover the rest. Now, what I don't have on there is how to do things like Lewis structure of a compound, which we've covered already, it will be on test 2, and also how to do ions, and how to, here's some ions, what's the molecular formula. That you have to memorize. But to think about it, in the past, students in my class would also have to memorize everything on that piece on the screen. You don't. That's my gift to you. All right, any questions on how to know what numbers to put in the ratio? Is it clear now? And if you want, you can always go back and go to my YouTube channel and see this lecture and rerun it. All right, we're talking about molar mass, which a lot of people call that. Dr. White calls it the molecular weight. And the molecular weight is the sum of all atomic weights in a molecule. And we did some of these. I think let's do one more, because it's an important skill to have. All right, let's look at the following. And I need something else right now. I know most of them by heart that I use, but you don't, and I don't expect you do. You know it. All right, the question is, what's the molecular weight of the following? And remember, the molecular weight is the sum of all atomic weights. So I'm going to let you, because I've got to share the fun, try A. And if you can't see it, the atomic weight of sodium. Now, remember, my gift to you the other day was for all atomic weights, when you're calculating molecular weight, use 3 significant figures. And for sodium, that would be 23.0. And for chlorine, that would be 35.5. So why don't you calculate the molecular weight of sodium chloride? Sum of all atomic weights. Is that better? Sodium is this one. Chlorine is this. Thank you. don't have a calculator, you can't add it up in your head. Okay. I don't know if they even teach that anymore in schools because they assume everybody has a calculator. That's sad. All right, let's do it. All right, what? That pen. How do you do molecular weight? Sum of all atomic weights. Sodium 23.0 and chlorine 35.5. Add them up. And you get 58.5. And that's an important skill. Let's see if Dr. Wake did this right. I don't think I've mentioned this before, but I think you're all familiar with Wikipedia, which I used to call years ago Wikipedia until my students used to scream, no, it's Wikipedia. But anyways, it's been so heavily policed by people like me. Yes, I've asked for changes in Wikipedia in chemistry. Anything else I can't guarantee. But in chemistry, it's been a couple of years since I saw any serious mistake. And the one nice thing about Wikipedia for different compounds and elements, they give important information on the right side. And if you notice right over here, molar mass, I call it molecular weight, and here they round it off a little differently. They have 58.443. I have 58.5. Either one works. I've done calculations using my number that about $250,000 was riding on. Did I do it right or not? And you don't want to make a mistake when you deal with that kind of money. And this works. But one of the nice things, there's all different types of information and important things, physical properties. And those are right. I could argue this should be 58.4 something. It's not worth it. But anyways, it gives you all sorts of information. All right, let's go back and look at B, and I'm going to do that one. This is an important thing I want to teach you. Now, the question is, what's the molecular weight of calcium nitrate? And the question is, how do you do that? Well, it's the sum of all atomic weights. Now, here's where you got to pay attention. What are the different atoms? I have one calcium. How many nitrogen? Ooh, good question. It's in a bracket. There's one here, you multiply it, so it's 2 nitrogen. How many oxygen would I use for that? Well, it's in a bracket, here's 3, but there are 2 of them. 2 times 3 is 6 oxygen. So, this is equal to 1 times, and what's the molecular weight, atomic weight of calcium? And let's look over here. And through 3 significant figures, I'll give you 3 seconds to figure it out, and then I'll do it. Times up would be 40.1. Nitrogen, I know by heart, 3 significant figures is 14.0. Oxygen, I know by heart, because I use it a lot, is 16.0. So now we have 40.1, 20, 28.0, and 96.0, if I did that correctly. Yep, I think I did. I see people agreeing. Thank you. And now I'll add it up. And the number I get, if I did my math correctly, did I do it correctly? Look out, I'm on a winning streak. And is this number. Now, how do you know what the right number is? You have the same number for addition is different than multiplication division. For addition, you have the same number of significant figures past the decimal point as the number you're adding that has the fewest significant figures past the decimal point. When you have a decimal point, which these all do, zeros past the decimal point are significant. So, 1, 1, 1, 1, I'm done. It took me a while, personally, to come to grips with, even though this is 4 significant figures, if you look at it, stuff to the left, you don't change when you're doing addition. And that's just the rules, and they work. Oh, let's do one more. What would be the molecular weight of calcium chloride? Hopefully we won't need any more. I already told you calcium has atomic weight of 40.1, and chlorine, rounding it off to 3 significant figures, is 35.5. And why don't you try and figure that out? I think I'm up to about 86.7% of knowing your names and working on getting that up to 100. When you're done, look up and smile. Oh, it works. I saw some smiles. And some frowns. Don't say that again. All right, let's do this. How do we determine the molecular weight of calcium chloride? We have 1 calcium. And notice we have 2 chlorine. And if I look over here, calcium has the 3 significant figures, and it's over there too. But I want you to get used to looking at a periodic table and rounding it off, because under test number 2, in test number 2, it'll be 3, 4 in the final. Underneath your name, now we'll say 1, use all proper significant figures for all calculated answers, and 2, it will say, please use 3 significant figures for all atomic weights. And actually makes your life easier. Now, chlorine, which I had before, is 35.5. Let's see if I was right. I was. And now there are 2 of them, so that's why I multiply it. This is 40.1. That would be 71.0. Wow, that's interesting. It'd be 111.1. 1 past the decimal 1. I don't have to round up. And that's how you do molecular weight. And you'll see almost instantly in a little while why that's an important thing to know how to do. All right, now, the whole mole concept, moles, chemist counting unit, is one of the most powerful things in all of chemistry that I know of, and I bet anybody knows of. And when I say I bet, I know I've won already. Now, moles, as you know, 1 mole of an atom equals, or element equals Avogadro's number of atoms, 6.02 times 10 to the 23rd, and 1 mole of a molecule or a compound equals 6.02 times 10 to the 23rd molecules. Now it turns out there's another way of defining moles, and that's called molar mass. And molar mass is, for an element, the molar mass, and for this class I'll use grams, you can use other units too, is the quantity in grams of that element equals the atomic mass of an element. So if I wanted 1 mole of gold, I'd look over at the periodic table and see on this one that it's 196. Let's go to 3 significant figures. 197 is the atomic weight. So 1 mole of gold in grams. Let me bring up the periodic table. One mole of gold would be 197 grams. So the atomic weight equals the number of grams 1 mole of that compound equals. And we'll be going through a lot of this, so. Now the other definition for compounds, it's called the molecular molar mass. I just call it, I don't even use that term, I just say what 1 mole of a compound equals. The quantity in grams of the formula mass, also known as the molecular weight of a molecule, equals the formula mass of the molecule, which in other words, if you have the molecular weight of a compound in grams, that equals 1 mole. And if you look at the next slide, anybody, remember anything I put up here is available to you in Blackboard. This is the most important thing. This is probably one of the most powerful things I know of all in chemistry. Set a record, use 5 exclamation points. You know this is important, and it is. And what I just said was, and what you should know is, 1 mole of an element equals its atomic mass or atomic weight in grams. 1 mole of a compound equals its formula weight or molecular weight in grams. And that allows me to do a lot. And we'll learn about that next week, this week and next week. But 1 mole. So if I were to ask, go out and bring back 1 mole of water. Anybody here see the molecules in here and count 6.02 times 10 to the 23rd molecules? No. Unless you're Superman or Supergirl. Is there Superwoman? I don't think they ever use that. They call her Supergirl. You don't have, I don't have X-ray vision, you don't, or microscopic vision or whatever. But we do know this. And the question would be, what does 1 mole of water weigh in grams? If I were to ask you, go to the lab, here's some water, you can get it from the lab, bring me back a mole of water. Well, how do you do that? Well, you look and know that 1 mole equals the molecular weight of water. So 1 mole, let me put this up here. One mole of a compound equals the molecular weight of that compound. Well, we did water, and what's the molecular weight of water? Let's do an instant replay. 2 hydrogen, 1 oxygen, 2 times 1.01, that's the atomic weight of hydrogen. 1 times 16.0, that's the atomic weight of water. And therefore, the molecular weight is the sum of these, 2.02, 16.0, 18.02. Round that off. 1 past the decimal, 2. I should have 1. Keep the 0. Keep the drop to 2. The molecular weight of water is 18.0. And therefore, if I wanted 1 mole of water, I'd weigh out 18.0 grams. And therefore, if I need a mole of water, 18.0 grams. And that's why it's important to be able to calculate molecular weight. Because 1 mole of a compound equals its molecular weight, shorthand, of a compound. Question?
Wouldn't oxygen be like 8?
What?
Wouldn't oxygen be 8 instead of 16?
No, it's 16. Hold on, let's find out. Your question is, did I have the right atomic weight? Well, let's find out. Last time I checked, I don't walk on water. Okay, you were thinking water. There are a few of them I know by heart because I use them. Hydrogen, carbon, nitrogen, sodium, and oxygen, and chlorine. I've used so many times in my life, they're just burned in here. But anyways, it's a good question. And now you know. So I think what you're thinking of is before I used calculated 18 for the molecular weight of water. And if you're not sure, don't assume. Did I teach you about don't assume? You assume you become the first 3 letters, which you don't want to be. And I didn't say, oh, I got to erase that off the video. But really, never assume. Every time I've ever assumed, I get burned. And like you assume what a person's feeling. No, you don't know what a person's feeling, even if you look at their face. You never can guess. And there are other things too. The other thing I learned in life, which I was taught, common sense is not common. I think I've mentioned it before. Anyways, let's get back to this. 1 mole of a compound equals its molecular weight. At the same time, I can also do this. I complained about the boards being dirty, now they're slippery. One mole of an element equals its atomic weight in grams. Both these are in grams. And 1 mole of a compound of an element equals its atomic weight in grams. You will be given this for test 2. So you don't, in the past, I'd make students memorize this. You don't have to memorize it. Now, at this point, a lot of students get confused. And the confusion comes with, well, Dr. White, you said 1 mole equals so many atoms, Avogadro's number, of an element, and it also, for a compound, equals so many atoms of, or molecules of a compound. How can it also equal 1 mole of a compound equals its molecular weight, 1 mole of an element equals its atomic weight? How can you have 2? And I thought about how do I best answer that and help with eliminate that confusion. I came up with the following. Let's assume you go to your favorite big box store, you order online, a dozen ping pong balls. Or you can pick anything else, but assume each ping pong ball, say that 5 times quickly. But anyways, each ball is identical, both in size and weight. Well, if you have a dozen, how many do you have? 12. But how much do 12 weigh? Well, you multiply the weight of 1 ping pong ball times 12, and you get a number, let's say 100. So whenever I have a dozen ping pong balls from that company, they're always going to weigh 100, let's say, grams. And the same thing applies to molecules or atoms. You can look at how many you have, and then since they're all identical in terms of their weight, how much does that weigh for 1 mole, which is Avogadro's number always. And that way you can come up with two separate definitions, but really interact and come from the same origin, that 1 mole of a compound equals Avogadro's number, but at the same time, 1 mole of a compound equals its molecular weight. And also 1 mole of an element equals Avogadro's number of atoms, but at the same time, 1 mole of an element equals the atomic weight of the element in grams. Now in here we can use grams in industry, same thing. We call this, and I won't use it ever again, these are gram moles, because you're working with grams, but you can also have pound moles, kilogram moles. I've worked with pound moles. Like I said, the largest calculations I've done was about 180,000 pounds total weight of everything I'm measuring, and that was about $250,000. You do not want to make mistakes when you're dealing with that kind of money. All right, it was fun to do though. So based on that, it's practice time. Let's do a few easy ones. And the question is, determine the mass in grams, or otherwise known as weight, which I'll probably use, for 1 mole of the following. Well, how do you do that? Ooh, silver. Well, what is silver? It's an element. And let's go to our periodic table. And if we look at silver, and you learned that it's Ag, the 3 significant figures, what's the atomic weight of silver? It would be 108, and therefore, if I said to you, everybody, on Friday, each of you bring in a mole of silver for me. That would be nice, I can't do that, but if I did, each of you would bring in 108 grams of silver. I'd actually say more than 1 mole, because I'm greedy, but that's how you do it. Remember, the atomic weight of an element equals 1 mole of that element, and that's in grams. If we go back to here, we did water, and now, ammonia. How do you figure out what is the atomic weight, or the molecular weight of or the weight in grams of 1 mole of ammonia? Well, first of all, I need the molecular weight. So I have ammonia. We've done this already, but I'll do it again. 1 nitrogen, 3 hydrogen. I just calculated the molecular weight of ammonia, NH3. It's the sum of all atomic weights, 1 nitrogen, 3 hydrogens, 1 time the atomic weight of nitrogen, 14.0, the 3 significant figures. The atomic weight of hydrogen, the 3 significant figures, is 101. Multiply that times 3, you get 303, add it up, you get 17.03. 1 past the decimal, 2, therefore I should only have 1. Keep this, use that to round off. The molecular weight of ammonia is 17.0 grams, or 17.0, and therefore 1 mole of ammonia equals its molecular weight, in this case for ammonia, is 17.0. Sodium hydroxide, I'll let you try at home, but that's, if I remember correctly, 40.0, because I use that number a lot. All right. Let's have some fun with this. Remember, I'm a chemist. let's look at the following, and sometime in the future, I would put on a piece of paper to hand out 5 points. How many moles of water are in 39.6 grams of water? What do you do? Well, first of all, I'll let you all have time to write it down. Tonight at midnight, I'll be giving speed writing, note-taking lesson, I won't. All right, what are we being asked to find, unit-wise? Moles of water. What are we given? Grams of water. If I can hear it, you guys should be able to hear it too. Always feel free to close the door. All right, now, how do we proceed? Well, this is the only number I have, so I have 39.6 grams of water. And guess what time it is? Yes, it's time to use your good buddy, your good friend, unit analysis. And if I can do one ratio, wow, time flies when you're having fun with moles. But anyways, if I could, in one ratio, what would the units of my answer be? Well, you have it over there, moles of water. Everybody think with me how I got to this point. This is what I have. This is the units I want to get my answer in. If I could have a ratio, now what would it be the ratio? Well, here's where you use your good buddy, your good friend, and my good buddy and good friend, your analysis. Whatever unit you're trying to get to goes on top, and that's moles of water. Whatever unit I'm trying to get rid of goes down here. Now, where do I get those numbers to put in there? You know, and you'll be given this, 1 mole of a compound equals its molecular weight. Oh my goodness. He didn't give me the molecular weight. So you have to calculate that, and I might make this 8 points, because it's more work. And the molecular weight of water, 2 hydrogen, 1 oxygen. We've done this, so I'm going at warp drive. Is 18.0. So I know 1 mole of water equals 18.0 grams. Knowing that, I can put 1 here, and then moles of water, I know 1 mole is 18.0. Everybody see where I got those numbers? And again, when you have 2 things equal each other, you can always put them in ratios like this. We've done it before. And now, let me remind everybody, this is an exact number. But before I go any further, I'm going to check my units to see if I can set this up. Grams of water times moles of water divided by grams of water. And anything divided by itself equals number 1. This cancels out. I'm left with the right unit. So now I can go ahead to my calculator. And my wow, that's unusual. And I hit it right on the head with an exact number sort of like that. But anyways, if we look at this, 3 significant, 3 exact number, 3 significant. How do you round that off to 3 significant figures? By the way, 10 to the 0 is the number 1. In case you ever see this on your calculator. So 1 times 2.0. 2.20 is 2.20. And that's how you do it. And it's all based on the knowledge that 1 mole of a compound equals its molecular weight in grams, and 1 mole of an element equals the atomic weight of the element in grams. Any questions so far? In that case, let's do another one. All right, next question, and this would be probably about 4 points, 5 points. This less work. How many grams silver are in 5.11 moles of silver? What are we being asked to find? How many grams of silver? That was easy. What are we given? Well, there's only one number there. And how do we proceed? Well, this is the only number I have. And what units do I want my answer in? Well, I took the time to figure it out. I have that. Now, if I had a ratio, and now it's time to use your good buddy, your good friend, your analysis. And I could convert this to this. What would be in that ratio? I'll slow down and let you all catch up while you're doing that. I'm going to have some water, which you know is 18.0 grams per mole. I wonder how many moles of water I just drank. All right. How do you figure out what's in that ratio? Whatever you're trying to get to goes on top. And I've made a mistake. It should have been grams. Somebody should have caught me. Because immediately when I saw that, I saw this isn't going to work. Whatever I'm trying to get to goes on top. The units I'm trying to get rid of goes underneath. Where do I get these numbers? 1 mole of an element equals its atomic weight. Therefore, I look at my periodic table, look at silver. It's 108, the 3 significant figures. Moles divided by moles equals number 1. I'm left with grams, which I'm trying to get. I come over to my calculator. And this is what my calculator gives me. It's a multiplication division, exact number, 4 significant, 3. And my answer should have the same number of significant figures as the number I multiplied by 3. Let's round that off to 2 significant figures. And that would be 5.52 times 10 squared. And that's how many grams you have of silver. You have those many moles of silver. And with that, we still got 40 seconds. Now, everybody, have a good day today. It's nice out for those who have lab tomorrow. Don't forget to check your email. Bring your lab, and bring your safety goggles. And remember, it's getting warmer out. No shorts, no open rips, your jeans, leggings, or anything else.
Yeah, it did.